Okay, for this video, I want to talk about the volume of a cylinder and the volume of a cone. If you go on the internet and watch some videos on both of these about the volume of a cylinder and the volume of a cone, you'll see a lot of examples of how they fill up the cone and pour it into the cylinder, and it makes good use of the formulas that go along with these. So right off the bat, I'll put the formulas up here. So the volume of a cylinder is nothing more than the volume is equal to the base times the height. Now this base, think about a cylinder. A cylinder has what kind of base? It has a circle base. So that base really turns into pi r squared times height. Okay, so that's the volume of a cylinder. Now on the EOC formula sheet, you will get this, and you will have to decide what kind of base that your 3D picture is talking about. Okay, so that's it for the volume of a cylinder. It's the area of a circle times the height. Now, of course, this is your base, and this is your height, right? You see that? That's your height. All right, so that base is a circle. Now, you talk about the volume of a cone. When we watch the video, terrible picture, sorry. When we watched the video, we talked about how many times a cone could fill a cylinder. Now, this cone and cylinder have to be the same height and have the same diameter. In order for this to make sense. So when we talk about it, if you go online, you'll see it. There are 3 cones to fill up a cylinder. So if you took this cone and you started to fill up the cylinder, 1/3 of it would be 1 cone. Is that a third? That's kind of short of a third. 2 cones, and then 3 cones. So it takes 3 cones to make 1 cylinder. So the formula for a cone is just 1/3 times pi r squared times your height. So it's the exact same formula, but you only get 1/3 of it because it takes 3 cones to make up a cylinder. So these two are real good formulas to keep in mind. Okay, so let's do some examples. Alright, so you got that. So I can do an example. So let's do an example of a volume of a cone. And, sorry, I didn't mean cone. I'd rather do cylinder first. Cylinder, let's do cylinder first. So if I have a cylinder, your typical cylinder, of course my drawing stinks, so just, bear with me. If you have a cylinder and they tell you what the radius is, perhaps they tell you that this radius is 6 yards. And the height is 11 yards. It is nothing more than filling it into the formula that you remember. So volume is equal to pi r squared times height. So if I take my volume, pi, plug in my radius, which is 6, and my height, which is 11, I can put that in my calculator and solve it and get an answer of 1244.07. Now volume is cubed, it's 3-dimensional, so your unit of measure should have a 3 on top of it. Okay, so that's pretty easy. All that is just filling into the formula. Now, you may have to find the radius of a cylinder. So let's try another one. I know, it's terrible. Alright, how about if I have to find the radius, that means I'm looking for that guy, but I'll be given the height. So the height will be 10, 10 yards. Alright, so I'm going to set it up the exact same way. I got to have the volume, don't I? So my volume is 125.66 yards cubed. So that's the volume of this, and I want to find the radius. Find radius. Okay, so if I find the radius, I've got my formula. My formula says take the volume and set it equal to pi r squared times height. Well, I don't know my radius, so I'm going to leave it as r, but I do know my height. My height is 10. Okay, so once again, all we want to do is solve for r, so that means everything on the right-hand side has to move to the left-hand side and leave r by itself. So I'm going to divide by 10 pi. I can do that because this is all multiplication. I'm going to divide this side by 10 pi. So when I do that, remember that if you have two things in the denominator, it needs to have parentheses. Okay, so 125.66 divided by 10 pi. And you get 3.999. So we're going to say 4. And we have the radius squared. So at this point, we get rid of that 2 by square rooting it. It's always the last thing we do. And the square root of 2 is, square root of 4 is 2. So my radius for this particular problem is 2 yards. Okay? So that's when you want to find the radius. Now what if I wanted to find my height? Let's try one more. Alright, so come over here, get rid of all this. Get rid of that little ugly part right there. Oops, have to be the same. I'm making a big mess. Has to be the same diameter. And that goes with that top part up there. Alright, so a cylinder. Let's say we have this one. And I was actually given the diameter. And when I'm given the diameter, I have to be careful that I make sure I only use the radius. I'm not given my height, but I am given the volume. So 4976, 4,000, 4976.28 kilometers, sorry about that, cubed. Okay? So, and I need to know the height. So what is the height? Alright, so volume of a cylinder is pi r squared times height. I know my volume, so 4976.28 is equal to pi times my radius. Whoop, now I've got a diameter. So my diameter is equal to 24, but I have to half it to get my radius, which is 12. So 12 squared times h. All right. Well, I know 12 squared is 144. So 144 pi times h is equal to 4976.28. And you have to divide by 144 pi. And remember that when you divide by two things in either the numerator or the denominator, or more than two things, it has to be in parentheses so the calculator does the operation correctly. So when I take that and divide it, I get 10.99. So I'm going to round that to 11. And that 11 will be my height. So now I have found all the missing variables that I can find. So that's a cylinder. So that's not too bad. So let's go on to a cone. Okay. So now when I talk about a cone, remember it takes 3 cones to make up a cylinder. So when I do the formula, volume of a cone is just 1/3 a cylinder. So 1/3 times my cylinder formula, which is that. Now on the EOC formula sheet, you're going to see 1/3 times big B times H. And you have to remember that the big B stands for the base of the cone. So your cone has a base that's a circle, okay? A circle base. So as we look at cones, let's see, we can have some typical examples if we're told that the radius is 6 and the height. Now the height of a cone always has to come down from the vertex straight down to use the height. It's not your lateral height, it's just your height is what you want. So let's make this a height of 10. So now we can plug this into our calculator. We've got our volume is what we want. So we have 1/3 times pi times 6 squared times height. Now you can do this any numbers of ways. You can put the whole thing in your calculator. As long as you put this in parentheses, you can put it in just in one big old long line. So that's what I'm going to do. Times pi times 36 times 10. And you get that the volume of this cone is 376.99, so I'm going to round it to 377. Okay? So that is a cone. Now, if you wanted to find, by chance you wanted to find the radius or the height, you're going to do it the same way we just did the cylinder. So let me find the right page. I'm sorry, I thought I had it there. You can go to any website and type in volume of a cone, and there's a ton of pictures and problems and those kind of things. Okay, so let's see. What's another word? Here's a good thing. What's another word for height? Do you remember? It's called the altitude. So if I drew a cone, let me at least label it for you, I guess. So if I drew it, that's kind of my spiffy little drawing there. Of course, it doesn't look like a circle because I've kind of half-mooned it, right? Oh, that's terrible. Let me start over. All right, let's try that again. That's better. It's not great, but it's better. So this would actually be my vertex. This is my base. And the height comes directly from your vertex down. This is called your height or your altitude. They're the same thing. Okay? And then the surface of this cone is actually called the lateral surface. So those are parts of our cones that we talked about. Alright, so let's try another problem. Probably should have done that discussion first, right? I'll leave that up there. I'll change my cone. Let's find the radius. Let's find the radius. Let me find another problem. How about this one? Oops, circle it. So here is, oops, let me pause this for just a second.